Yeah, go ahead.
I didn't get my test results for the mock test.
You should have the score. You should know your score. It's automatically graded.
Okay.
There's a score button.
It didn't show anything for me.
Okay,
And
I'll show you. Maybe, Sarah, maybe you can send some instruction.
Yeah, when you submit it though, there should be a big purple button that says view score, and it'll tell you what your score is, what you got right, what you got wrong.
Oh, okay. And I also didn't get the email that Mr. Dang sent.
Okay. Did you put your email in the? No, it's actually your parents' email. You're a sixth grader, right?
Yeah, I'm a sixth grader.
Yeah, sixth grader is too young to be added to a group, so it must be your parent must have received it. And what I'm going to do is, I think I'm going to do is to create just a mail list. The mail list, the problem of a mail list is everybody can see everybody's email, so it's a little bit less private. But I think we'd rather going that way than not receiving emails. So I think that's what I'm gonna do. So I'll create an email list and everybody should receive it, except for PUSD. Okay, so I still see some PUSD email. PUSD email is not public approachable, so I better be a Gmail, Hotmail, anything like that. Okay, I'd like to go through the homework just a little bit. Which one is most problematic? Let me see.
Mr. Dang?
Yeah.
And also, are we gonna be getting separate coaches?
Right now, I'm not looking at separate teams. It's just because most of people are really comfortable in this pace, and what we're looking at is one team, and every coach will come to this team to give a meeting lecture, and we're trying to make one most acceptable pace for the students.
Okay.
But that might subject to change, so I'm still deciding right at this point. It just doesn't look like I'm going to separate team, simply because the really very few feels left out or can't catch up in the first meeting. We can't just have a separate team just for 2 or 3 people. And besides, we don't really have enough coaches to coach the second team. Okay, but I will update to you officially once this decision is made. Okay. All right.
And I didn't get the homework email too. I don't know what the homework is, and I didn't do it because I didn't get any email or information about the homework. And my mom didn't either. And my mom didn't either.
Okay, we'll talk about that offline. That's
Okay.
very weird. Somehow somewhere got disconnected. How many of you haven't received any email about homework? Okay, 1, 2. So I can't see all of you. That's okay. Just put it in the chat windows. It's not if it's in your email, just you didn't see it, you didn't take a look, that doesn't count. If you have an email, either you or your parents have not received it, put in your chat window. Okay. All right, let's continue. I think I'm gonna go over the problem 3 because that's what I see a lot of issue here. Can you guys see the problem?
Yeah.
Okay, thank you. So I'll read aloud. So Jane writes the integer from 1 to 2000 on a piece of paper, and she erases all the multiple of 3, then all the multiple of 5, and so on, erasing all the multiples of each odd prime. And how many numbers are left when she finishes? I found these hints are really useless. It shouldn't be there, in my opinion. But so here's the thing: we have 2,000 numbers for 1 to 2,000, and we removed the multiple of 3 and 5 and so on. Does each odd prime, and what are the numbers are left? Okay, and I'd like to ask someone to share your thought. I see Sarah, you're raising your hand. Go ahead. Tell us what
I can.
Go ahead.
So what I did was I noticed that every single number except for the powers of 2 would be erased. So I just counted the powers of 2 in 2000 and I got 11.
Okay, hold on. Slow down just a little bit. So you're saying if you just remove 3, 5, 7, blah, blah, 11, these multiples, what does it really mean? So you think when the multiple of these are gone, the only thing left should have the factor of 2.
And only 2.
And only 2. Does everybody agree?
Not factors, powers.
Well, that's the same thing because only 2. Only 2.
Hold on. Who is asking what question? Repeat again.
Abanish.
I wasn't asking a question. You said factor, and factor could mean 6, but 6 is a multiple of 3, so that would.
What we said is has a factor of 2 and only 2. Make sense?
Yeah, but wouldn't it be just easier to call it power?
Has power of 2 and only 2. What does that mean? Okay, I don't think that means anything. The number left should have, what's the factor? What's that? Or you can say what's a divisor? It should be, or you can say what's a prime divisor, right? Prime factor. It should be just 2 left. And how many 2? We can say it could be 2 to the 0, could be 2 to the 1, 2, right? Until at some point it's greater than 2,000 and it's out of range, right? So 2 to the 10th, what can we estimate as 2 to the 10th?
1,024.
Yeah, let's just slow down a little bit. So 2 to the 10th is 2 to the 5th square, right? And to the 5th, we know it's 32. So 32 square is, let's calculate it. Yes, 1024. That's exactly right. So we know 2 to the 10th is too big, right? So it'll be, yeah, also we can't have 0, right? Because 2 to the 0 is 1. So really we're starting from 1 to, actually we do have 0 included. Yeah, because we only remove, and 1 is a valid number that's left, and we only removed all the other members. So 1 is left. So it's really should be 2 to the 0, 1, 2, all the way to 9.
Mr. Deng, I can't see the upper side of your whiteboard. It's not visible.
Yeah, that's okay. Does it make sense?
Kind of, not much. I don't understand how you got.
Wait, the answer is
to
11 or 10, Sarah?
11.
Oh, I'm sorry. This is 1024.
0 to 10.
Yeah, we need to do one more, right? So 2 to the 11 is something we cannot.
No, 2 to the 11th power is
2
2040.
to the 11 is the one that we can't do anymore. So we can do all the way up to 10. Yeah. So
that's why it's 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
yes, correct.
I do not understand how you got to like 2 to the power of so on.
Yeah. I mean, that's just something we have to convert from a word problem to mathematic formulation. So
yeah, it's just if she erases every single multiple of a prime number.
She's asking how do we know that only 2 to the power of something will be left?
I understand what she's asking. That's what I'm saying. That's my response to it. That's how you convert a word problem to math formulation. This is hard. And how can you say, okay, I just remove multiple of 3, 5, 7. Why do you say what's left is only have power on divisor of 2? This is just some way of you have to think that way. This is what's left. Anything else, it won't be there. The only prime factor of the numbers that left would be 2. Okay, that's it. And that means you have 2 to the first, 2 to the second, 2 to the third, until 2 to some number that's exceeding 2000. That's all. Okay. Yeah, we're not spending too much time on it. I'm trying to pause the sharing so you can see the whiteboard better, but I forgot how to do that. Something about Spotlight. Oh, okay. Let's see. Oh, I will have a Spotlight. Okay. I think the rest of the problem are pretty straightforward. Anyone that have worked on all of them feel necessary to go over some other problems here? Okay, actually, the problem 8.
I can answer 8.
Yeah, let's go to the problem 8. Go ahead.
So for this, first I figured out that if both of the numbers are the same and the factor of this would have to have 1 in some way, because 1 times any number equals that same number. So it would still come back to normal and that integer would stay the same. And then if the number, and then I just figured out it was 1001, because 1 at the end times 256, for example, would be 256, 256,256.
Did I mention this in the class, in the meeting last time? Were you
Yeah.
in the meeting? Okay. Yeah, this is exactly what we went through last time. I'm going to show you where. Okay, so this is so why is it so small?
Click zoom out. Zoom out. Like control and then zoom out.
Control
minus. Control minus.
Let me see. Oh, thank you. Okay. So it should be somewhere here. Nope. Okay. Yeah. See this one? What is different between large and smallest prime factors? 15,015. We have set in here. For any 6-digit number formed by repeated 3 digits, we'll have a divisor of 1001. And this is exactly what we're talking about. And in this case, it's 15, but in that case, it's 256, or anything repeated, that's 1001, okay? There's no more common divisor because it's gonna be 1001 times any random number. It can be anything. So 1001 would be the biggest factor. Now, just to remind you that 1001 itself is an interesting number. It has the divisor of 13, 11, and 7. So 3 prime factors. Okay. Okay, since we're here, so last meeting we didn't really do a lot, but we briefly, for the ones that joined today, we briefly talked about how to get better on math. We want to take note. We want to revisit. Okay. And I hope somebody has started already, if not. And we have one important thing about counting how many divisors is we look at their prime factorization, and we only look at the exponent. Okay, we got exponent, we get all exponent plus 1 and multiply together. This is the total divisors. Okay. And here's a question I want to ask everybody. Last time I didn't get a chance to ask. So at what condition a number have odd numbers of divisors? Okay, think about it. Think about it. Just Sarah, give a minute, give a half a minute or something. So what kind of number? Instead of saying what condition, just say what kind of number will have odd number of divisors by looking at this, right? By looking at this. All right. Okay. Arjun, are you raising your hand?
Oh, no.
Okay. What about Elaine? Any idea?
Square numbers.
Perfect. Perfect. Can you explain why square has the odd number of divisors?
Because, for example, 64 is 8 times 8, and you would only count 8 one time.
Exactly.
A factor.
Yeah. That's very good. Thank you. Yeah, so it's going to be square or perfect square. They have odd numbers. Why? Look at this. See, if this thing is an odd number, it means every single one must be odd, right? If anyone is even, the whole thing will be even. So it means every single thing will be odd. It means every single exponent is even, right? If there is, and everything is even, that means it must be something square. The whole thing must be something square. Make sense? Cool. Thank you. And this is a very useful conclusion, which I will apply it directly in one of the problems we're going to go through today. Okay. So only the square number will have odd number of divisors. All right. And
Just to let you know, you have 2 minutes until the meeting ends.
Okay, so if meeting ended, let's just redial the same one, click the same meeting, come back. Okay, hopefully we don't get kicked off this time. And last time this problem wasn't gone through very well. I just want to spend just a little bit more time in here. Okay, so 50, the problem is, let me read the problem. Okay, so the problem is how many divisors of 5400 are not multiple of any perfect square greater than 1. Okay, not multiple of any perfect square greater than 1. All right, so I'm gonna stop sharing so you can probably see my board better.
You could just pin yourself.
Okay, I'm pinning myself. Does that help? Okay, and not remove our spotlight, but I don't know what that means. Okay, so do a little bit taller. And hopefully this works. Okay, let's use this half then. So 5,400. Okay, we already know this is okay, 10 times 10 times 54. 54 is 6 by 9, right? So 6 is 2 times 3. 9 is 3 times 3, so that's 3. And 2 times 5. So we got 2 to the
2
third.
to the third power times 3 to the third power times 5 to the third power.
5 to the third. Perfect. Thank you.
Second.
Okay, let's just wipe up this so it's easier to see. So it's kind of low, huh? Okay, so it's 5,400 is 2 to the third, 3 to the third, 5 to the square. Okay. All right. So how many divisors? The divisor must be the one of the prime factor.